Okay, so we've been looking at prime number programs, and I thought I would do the next problem from Project Euler, problem number 7, which is to find the 10,001st prime number. Because it's very similar to the last program we did, but there's a little bit of a. I mean, the last program we did was just to find the prime numbers up to some certain value. We know how to do that. But this is a little different because we don't know how big the 10,001st prime number is. In the last example we did, we're finding the primes up to 100 or up to 1,000 or up to 1,000,000. But in this case, we don't know how high we're going to have to go. So we're going to have to change our program a little bit. We'll still use the same for loop to check to see if a number is prime, but we won't know how to stop until we count how many primes we found so far. So a for loop isn't going to do it for us. Remember, those of you who took the class with me last semester, I said that if you know how many times you're going to have to do something, a for loop is probably the best choice. If you don't know how many times you're going to have to check something, if there's some condition that you don't know if it's met yet, a while loop is probably the best choice. So today we're going to learn how to use a while loop in Java. So we're starting with basically the same skeleton we started with before. The problem is to find the 10,001st prime number. We'll still need a variable for all the numbers we have to check. We'll still need a variable, an integer variable for the factors that we test for divisibility. Is it divisible by 2 or 3 or 4 or 5 or 6 and so on. And we'll need a Boolean variable that we assign the value of true if something is prime and false if something is not prime. In the last program, we had a variable that was the running total, the sum. We were adding up the primes, but that's not what we're doing this time. We're just counting the primes. So I'll create an integer variable called prime count. And we'll start it at, I guess, 0, because we haven't found any primes yet. So we'll initialize that variable with a value of 0. Now, we need a loop to go through the numbers from 2, we don't have to check 1 because 1's not prime, from 2 up to our maximum, whatever it is. Our maximum here is 10,001. So we'll have a while loop, and we're going to go while our prime count is less than 10,001. Should it be less than or equal to? It depends on when we increment that variable, when we increase it by 1. But for now, I'm going to make it less than. We'll make sure it works. We'll make sure we're incrementing it in the right place in just a minute. Just like last time, we're going to assume that every number is prime until we find a factor. So we'll start, is it prime equal to true? And then we will check our numbers in a for loop that tests for divisibility with the factors that go 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to copy and paste, actually, that for loop from our last program because it's exactly the same. So here's our for loop. For the factor starting with 2, going up to half the number, and increasing by 1 every time. This is our Java syntax for a for loop. If the number modulo the factor is equal to 0, in other words, if it is divisible by the factor, set the primeness Boolean variable to false. Is it prime? No, it is not prime, so that's false. And then break out of the for loop. Once I find a factor, I don't need to keep checking. So that loop is just copied from our last program. That's how we check to see if a number is prime. What do we need to do if we find one? Well, that's a good question. At the end of our loop, we're going to have some kind of conditional that says, if is it prime is true, if I get through that loop and didn't find any factors, what do I do? I take my prime count and I make it 1 bigger. Now, this is the way I often do this. This is the way I often write this because I'm kind of old school and learned how to program in the 1980s and 90s. Prime count is equal to whatever it was before plus 1. That's a perfectly fine way to increment a variable to make it one bigger, and it's what I usually do just because I think it's easy to read, but it's not very compact. And the way that modern programmers do this in most modern languages is prime count plus plus. The plus plus operator increments the prime count variable by 1. Okay, so a variable with a plus plus following it just adds 1 to that variable and gives it a new value. And then as we find the primes, let's print them out to the consoles just so I can see the program is doing something. So I'm gonna do this with a copy and paste so you don't have to watch me struggle through typing this. Here's my print statement in Java system.out.println. The number that we just checked, and then the substring is prime, and then plus prime count. In other words, when we find a number, print that number, print the words is prime, and then how far we've counted, how many primes we've counted up until then. Okay, does that make sense? Now, there's one more thing we need to do that we didn't have to do in our last program. In our last program, we checked our numbers in a big for loop. And the for loop increments the number at the beginning of the for loop automatically for you. While loops don't do that. So if this is the end of my while loop here, I believe, unless I lost a bracket, I need to increment my number here. Number plus plus. That makes my number that I'm testing 1 bigger. So this, oops, I got an extra cap in there. This, I'll just put check the next number in the while loop. Okay. If I don't have any mistakes, I think that's it. Let's go ahead and run it and see what we get. See if we get any errors. There you go. It's printing primes, printing primes, printing primes. Okay. And this says what's that? 104,000. Oh, you guys can't see that. Can I turn me off? Can I scroll up? I can't. I don't know what to do. Let's see. If I move me in Code HS over here, I don't know what that just did. I don't know what that looked like. I've never moved the interface while a thing was recording, so we'll see how that worked. Excuse me. It says 104,743 is prime number 10,001. How do we know if we were right? We'll go to Project Euler, look at problem number 7, and the answer is already here because I've already solved this one, is 104,743. So we got it right. Okay, so that is how we use a while loop in Java. Very, very similar to Python. I'm going to move this back now. Whoa, that's not at all what I wanted to do. I'm going to move me. No, why isn't that working? Me over here. So we now have a little piece of code here that we can reuse. Anytime we've got a program about prime numbers, we can go back to this program and copy that code and paste it in and reuse it. I was looking at Project Euler, and I was looking at the archives, and I was trying to find what other programs involve prime numbers. There's number 7, we just did. There's number 10, the summation of primes. I think there's another one earlier. Oh yeah, number 3 is the largest prime factor. Number 3, find the largest prime factor of this number. What even is that number? That's millions. That's 600,851,475,143. That's problem number 3. We could probably do that given what we've learned so far. Number 10, find the sum of all the primes below 2 million. So start from 2, count up to 2 million, find all the primes, and add them up. we will run into a problem if we try to write code to do this using the algorithm that we just created. I just tried it a little while ago. And it bogs down at about 1 million because this algorithm that we've created here is not very fast. And CodeHS sort of limits the amount of time it allows a program to run on its server. When you run programs on CodeHS, it's not running on your computer, it's running on the CodeHS server and then sending you the results back. You can't run a program that takes 5, 10, 15 minutes to run on CodeHS. So if you try to do Project Euler number 10 with the code that we have created, it's not going to work. It's going to time out for you about halfway through the process. So what we will do, probably not until 2 or 3, maybe 3 videos from now, is we'll look at some algorithms for computing prime numbers more quickly, and for saving those prime numbers in a list so that we don't have to compute them every time we need them. We can just go back to that list. We'll have a way to create a sort of database of as many primes as we want rather than dividing everything by every number every time we need prime numbers. In order to do that, we need to know how to put things in a list in Java. Those of you who've taken Python know about lists. We used them a lot in 221. Lists are similar but different in Java. They have a different name, but they work in a similar sort of way. The methods that Java has for manipulating lists are not quite as robust and varied as the ones in Python. But what we'll do in the next couple of videos is we'll look at, rather than just seeing if a number is prime, we'll print out all of its factors. We won't stop when we find a factor. We'll keep going until we find all the factors. And then we'll put those factors into a list, and we'll see how lists work in Java. And once we do that, we'll be able to create a list of primes that will let us maybe do this problem, Project Euler number 10, do it in a way that doesn't run into the limitations of our CodeHS environment. It lets us get all the way up to 2 million without bogging down. So we'll look at that next.